students. Today I am going to revise the half of the ninth lesson. Okay students, we start from rectification process. Okay, see this, the process of converting alternating current into a direct current is called rectification, right? So this is the rectification process, and the rectification is a 2-mark question. Okay students, right? And there are two types of rectifier here, right? Okay, so rectification is a process, rectifier it is device. Okay students, so we are going to discuss about two rectifiers. One is half wave rectifier and a full wave rectifier. Okay, so half wave rectifier is a 3-mark question and the full wave rectifier is a 5-mark question. Okay students, right? And a half wave rectifier, yes, half wave rectifier. So this circuit consists of a transformer and a PN junction diode and a resistor. In a half wave rectifier circuit, either positive half or negative half, this line is very important, either positive half or negative half of the AC input is passed through while the other half is blocked. So only one half of the input signal is going to be rectified. So half wave rectifier, only half of the input wave only rectified, it gives the output. Okay student, right? Half wave rectifier circuit, 3-mark question, and the full wave rectifier is 5-mark question. Okay, right? Okay, and this rectifier efficiency, the efficiency is defined as the output is DC power to the input power, output to the input, that is the efficiency. Here it is defined as the ratio of output power DC power to the AC input supply to the circuit. The half wave rectifier efficiency is eta is equal to 40.6 percentage. 40.6 percentage. So this 40.6% is a 1-mark question. Okay, the same time, see, if the direction of the diode is reversed, if the direction of the diode is reversed, the negative half of the AC signal is passed and the positive half is blocked. 1 mark, right? And next, during the negative half cycle, when the negative half cycle input signal passed through the circuit and the terminal A is negative with respect to terminal B. So now the diode is reversed and do not conduct current. That means no current pass through load resistance in that circuit. Okay. Now the reverse saturation current in the diode is negligible. So therefore some voltage drop. If we go to the circuit, we will understand. Okay. Just you have to negative half cycle only here taken and the output voltage is presented. Okay students, right? Okay, right. And see this half wave rectifier input output. So the diagram is very important, therefore we should draw the diagram. So just see that input output. See, this is the input signal, this is positive half cycle and this is negative half cycle. Yes, input voltage, what the output voltage is, only see this, only positive half cycle, and here positive half cycle. Okay, so every positive half cycle only it gives the output. Okay students, right? We understand, right? And see this, the next one is, so here which one, full wave rectifier, full wave rectifier. See, this is the transformer and these are two diodes, D1 and D2 diode, and M1 M2 on the coil, when the current flow, and the R is the load resistance, and AAP is the positive negative applied voltage, positive or the negative of the applied voltage. Okay students, now come to the their in output input. See, this is the input voltage, this is the what, input voltage. See the output. So in full wave rectifier, yes, entire input signal going to rectification process and gives the output, because during each and is every half cycle, one diode under reverse condition and one diode under forward condition. So therefore in forward bias, the diode should conduct current, so it gives the output. So and another cycle, one diode under forward, another diode under negative, so reversed. So due to this reason, the diodes should conduct the current, so it gives the output like this, the output like this. Okay students, right? Okay, now their efficiency, important one mark. The efficiency of full wave rectifier is twice that of half wave rectifier and is found to be 81.2 percentage. 81.2 percentage. That means it is because both the positive and negative half cycle of the AC input source are rectified. Which one? Rectified. Okay students, right? So efficiency one mark. Efficiency of the full wave rectifier is 81.2 percentage. Okay, so in full wave rectifier, each and every cycle gives the output through the load resistance. Okay students, right? And see this here, this one note, this center tap transformer. So from this one mark will come, that's why I'm telling. Okay, so please listen. There is a facility to tap a halfway point in the secondary windings. So this helps to measure the induced voltage from one end of the secondary coil or secondary to the center point. If the center tap point is grounded, then the voltage applied across the secondary will be divided by half. For example, if the voltage applied across the secondary coil is 240 voltage, then the voltage drop across one end and the center tap point is one positive is plus 120 voltage and another end is negative 120 voltage. That means half, divided by half. Okay students, and next topic is breakdown mechanisms. So in current is PN junction, breakdown mechanism takes place. Okay, breakdown mechanism takes place. Basically Zener breakdown will be takes place and avalanche breakdown will be takes place. So therefore breakdown mechanism takes place in PN junction. Yes, see this, the reverse current or the reverse saturation current due to the minority charge carrier is small. So if the reverse bias applied to PN junction is increased beyond the limit, the junction breaks down and the reverse current rises sharply. The voltage at which that happens is called the breakdown voltage. It's called breakdown voltage. Please underline. So breakdown voltage is a 2-mark question, interior 2-mark question. Okay students, and continuation. And it depends on the width of the depletion region, which turn depends on the doping level. Depends on the doping level. Okay students, right? Okay, next, Zener breakdown. Heavily doped PN junction have narrow depletion region or narrow depletion layer of the order of 10 power minus 6 meter. This one is important 1 mark. Okay, please note it down. And next, when a reverse voltage across this junction is increased to the breakdown limit, a very strong electric field of strength 3 into 10 power 7 voltmeter power minus 1 is set up across the narrow layer. So the field strength is 3 into 10 power 7 voltmeter power minus 1. Okay students, 1 mark. So from this note, 1 mark. For a reverse voltage less than 4 voltage, Zener effect predominates, and greater than 6 voltage, avalanche effect S predominates. Between 4 and 6 voltage, both effect are present. So 1 mark. When we'll take the Zener and avalanche effect will be takes place. So like that the questions will come. Okay students, right? Okay, now come to this one. So this diagram is nothing but forward bias junction and reverse bias junction. Yes, so based on that, forward is current and here Zener voltage and that reverse current. So here the knee voltage, so knee voltage is not a particular voltage. Okay, so knee voltage for the germanium is 0.3 voltage, for silicon is 0.7 voltage, right? Now come to this one, constant voltage like this. Okay, constant voltage like this. Okay, students, right? Now come to this one, the maximum reverse bias that can be applied before entering into the Zener is called the peak inverse voltage. Peak inverse voltage, and commercially referred as PAV rating. So please underline PAV rating. Okay, and applications of Zener diode. See this, the Zener diode can be used as voltage regulators and calibrating voltages, and provide fixed reference voltage in a network for biasing and the production of any gadget against damage from accidental application of excess voltage. Which voltage? Excessive voltage. So these are the applications of which one? Zener diode, and there's 2 marks or 3 marks will come. Okay, students, right? And next, optoelectronic devices. The optoelectronics deals with the device which convert electric energy into light energy. So please underline 1 mark. And optoelectronic devices is an electronic device which utilize the light for useful applications. Okay, so what are the optoelectronics devices? LED is a very important device. LED, light emitting diode, and photodiodes and solar cells. These are 3 important devices for optoelectronic devices. 1 more question. Okay, students, right? Now come to the light emitting diode. So LED is a PN junction diode which emits visible or invisible light when it is forward biased. So please underline when it is forward biased. Since the electrical energy is converted into light energy, this process is also called electroluminescence. Please underline. Okay, LED. Yes, continuation LED. See that this is the structure of LED. Cathode, anode, diode, and P layer, active layer, N layer, substrate, anode, transparent glass. So these are the parts of the LED. So definitely you should mention the parts. Okay students, parts of LED, right? So in LED both N type present and P type is present. Okay, okay students, right. Now come to that LED. The LED are available in the wide range of colors such as blue color. Blue color due to is silicon carbide, and green color aluminum is gallium phosphide, and is for red gallium arsenide phosphide. Gallium arsenide phosphide, that is for red color LED. And nowadays LED emit white light, that is gallium indium. Yes, gallium, yes, indium is also available. Okay, now come to that applications of LED. Indicator lamps on the front panel of scientific and laboratory equipments. Nowadays we are using now, so all the indicator system in laboratory equipments, nothing but LED. And the 7 segment displays, right, 7 segment displays. And traffic emergency lighting, traffic lighting is separately we use the red color. And the last one is remote control of television, air conditioning, extra. So remote control of television, automobile, extra. Okay students, so these are the 3 marks and a 2 mark question. Okay, right. Next topic is photodiodes. The PN junction diode which convert into optic signal into electric signal. Okay students, right. And this is the diagram. Okay, this is the diagram for photodiode. Already we discussed. Okay students, application of that system. See that alarm system, count items on okay, conveyor belt and photoconductors, camplett displayers and smoke detectors, medical applications such as detectors for computer tomography. So these are the applications of what? Photodiodes. Okay, right. And next, solar cell. A solar cell is also known as photovoltaic cell. So this cell is converts light energy into directly into the electrical energy. So please underline. And it is basically PN junction diode. Yes, at the same time this junction which reversed or generated EMF when solar radiation falls on the PN junction. Okay students, right. And next, applications of solar cell. Solar cells are widely used in calculators, watches, toys, portable power supplies, and etc. And the solar cells are used in satellites and space applications. Solar panels are used together to generate electricity, right. And these are the applications. So definitely 1 mark and 2 marks will come. The students, right, applications of solar cell. And next is transistor. Transistor, right. So here NPN transistor. Which transistor? NPN transistor. That is what will come. And NPN transistor. The NPN transistor is P type and N type combined together to form a which one? Transistor. We already discussed what is transistor and working function. Okay, just I am recalling. So diagram here must. and from this one there are three terminals in transistor. One is emitter, base, and another one is collector. Okay, here base is given. Base is very thin, 10 power minus 6, and very lightly doped compared to the other regions. But collector, the main function of the collector is to collect majority charge carriers. Base and the collector. Base is the central region. Okay, collector, the main function of a collector is collect the majority charge carriers supplied by that emitter to the case.